Imagine the vastness of the solar system, with planets orbiting the sun, and now shrink that down, way down to the size of an atom. What if I told you there's a surprising analogy between the two? Today, we'll explore an intriguing idea. Could the structure of an atom mirror the layout of our solar system? While on the surface, this comparison might seem abstract, examining the atomic world through the lens of the solar system opens new ways to understand both the universe and the fundamental building blocks of matter. First, let's break down the traditional model of the solar system. At its center, we have the Sun, a massive star around which all planets orbit due to the Sun's powerful gravitational pull. The inner planets, like Mercury, Venus, Earth, and Mars, move faster due to their proximity to the Sun, while the outer planets, like Jupiter and Saturn, move more slowly in their larger orbits. In this model, everything functions through gravitational interactions. Planets, moons, and even distant comets are drawn towards the Sun, all maintaining a delicate balance in their orbits. Now let's look at an atom. The Bohr model, introduced in the early 20th century, describes an atom as having a nucleus at its center with electrons orbiting around it. This model, similar to how planets orbit the Sun, shows electrons maintaining specific energy levels, each orbit corresponding to a different energy state. Much like the solar system, an atom has a central force. This time, it's the positively charged nucleus that attracts the negatively charged electrons. Electrons stay in their orbits unless they gain or lose energy, moving between energy levels. Here's where the analogy starts to form. In both cases, you have a central body, the Sun or the atomic nucleus, and orbiting objects, whether they be planets or electrons. But the analogy runs deeper than just the structure. Let's break down how these two seemingly different systems share key principles. Both systems function through forces acting at a distance, gravitational forces in the solar system and electrostatic forces within an atom. These forces pull objects into orbit, creating a stable, predictable structure. Even though the solar system is governed by gravity and atoms by electromagnetic force, the principles behind the orbits share a striking similarity. Now let's imagine scaling the solar system down to the size of an atom. First, we would need to account for the significant difference in forces. While gravity governs the motion of planets, it is relatively weak when compared to the electromagnetic force that dominates atomic structures. If we scale the solar system down to atomic size, we would need to vastly increase the gravitational force to match the strength of the electromagnetic force between the nucleus and the electrons. In fact, the electromagnetic force is 10 to the power of 39 times stronger than gravity. In this scenario, gravity would behave more like the electromagnetic force, causing the planets to orbit much faster and more tightly, just as electrons are bound to a nucleus. Now, this change in force would also affect the frequency of orbits. As we reduce the size of the solar system, the frequency of the planet's orbits would increase dramatically. In atomic systems, electrons orbit the nucleus at incredibly high frequencies, which correspond to their energy levels. If the solar system was scaled down to the size of an atom, planets like Earth would orbit the Sun thousands or even millions of times per second, far faster than their current orbital period of 1 year. Another crucial aspect of this scaling is the wavelength of the planet's orbits. In atomic systems, the wavelength of an electron's orbit is tied to its energy state, and smaller orbits correspond to higher energy levels. Similarly, as we shrink the solar system, the wavelength of the planet's orbits would decrease, becoming minuscule compared to their real-world counterparts. Increasing the frequency of orbits would also lead to an increase in speed. At the atomic level, electrons move incredibly fast, often approaching significant fractions of the speed of light. If we scaled the solar system to atomic size, the planets would similarly speed up. Earth, for example, would travel around the Sun at speeds many orders of magnitude greater than its current velocity of about 30 kilometers per second. The faster orbits, combined with increased gravitational force, would cause the planets to behave much more like electrons in an atom. Scaling the system down would also introduce quantum-like behavior into our solar system model. As the orbits shrink and speeds increase, the planets may no longer move in smooth orbits, but would instead exhibit behavior more akin to quantum particles, where they exist in discrete energy levels or orbitals. The wavelengths of their motion, combined with the increased speed, would transform the solar system into a microscopic world where orbits are quantized. In this thought experiment, we've taken the vast solar system and imagined it on an atomic scale. We've seen how gravitational forces would need to be strengthened, how the frequency and wavelength of planetary orbits would increase dramatically, and how the planet's speeds would reach incredible levels. These changes reveal deeper parallels between the cosmic and atomic scales, showing that even though different forces and laws may govern these systems, there is an underlying connection between them. Thanks for watching. If you enjoyed this exploration, subscribe for more fascinating content. See you in the next video.